Hi, welcome to our math. Today I'm doing a series of videos on exponential functions. In this video, what I'm going to do is I'm going to take these three situations and write them as an exponential function. Challenge. At any point when you feel you understand this concept, try to do it before I do it. Okay, an exponential function is a function that can be written as f of x equals c a to the x, where c is our initial value, where we start, and a is our growth or decay factor. It's what we multiply by to move forward. It says write an exponential model for a population that started with 77 animals, that's our initial, and is shrinking by two-thirds its population every year. Well, if you're losing two-thirds, that means you have one-third remaining. You don't need to go to a lot of these questions have percents, though this video has fun, challenging ones. I'm going to take my f of x and write it as p of t. We're starting with 77 animals. Two-thirds is being subtracted from the whole population. Well, 100% of the population written as a decimal is going to be 1. So these formulas often have the number 1 involved. So we start with 100%. We're shrinking, that means decay, subtraction, by two-thirds. And then this is an exponential function, which means the exponent has to be a variable. You are more than welcome to rewrite this as p of t equals 77 times 1/3 to the t. They're the same thing. I think this one's easier to follow as to what's going on, though in the case of fractions, it's not too different. All right, write an exponential model for the population that started with 13 and is quadrupling. So in this case, you are just given the factor. Here you are almost given the factor. Here you are. Quadrupling just means you're multiplying by 4 each time. You don't need to do 1 plus. You don't need to do 1 minus. You are just given your growth factor. This happens a lot. Given growth factors that you see a lot. Growth factors. You'll often see double, at which point a is just equal to 2, nothing else. You see half-life a lot. Half-life is just when a is 0.5 or 1/2. Triple, when a is 3. You get the idea. You are often just given the growth factors, and when it's given to you, you don't need to alter it. You don't need the 1 plus, you don't need the 1 minus, you don't need anything else. You are just given the number to use in the parentheses. All right. And our last one is the most traditional of our exponential function setups. Write a model of a population that started with 72 animals and is shrinking at an annual rate of 21% per year. Well, percent literally means per 100. So 21 per 100 is 0.21 because we need to make our percent a decimal before we can put it into our function. Population over time. We start with 72 animals, and it says we're shrinking, so it's 1 minus 0.21 to the t. Again, if you really want to rewrite this as p of t equals 72 times 0.79 to the t, that's fine. I find this one's easier to follow. It's really easy to see that we have a decay rate of 21%, though this one is easier to type into your calculator and manage if you have to utilize this equation very many times. All right, I hope you've enjoyed this video. Please subscribe to my YouTube channel, like my Facebook page, and I'll see you on the next video. Thanks!